What actually happens in the first hour after a Yellowstone-scale supervolcano erupts? Not the disaster movie version. The measured one. This video works through 4 real numbers. 3 of them are well established. The 4th is genuinely disputed among scientists, and we're going to show you why, instead of picking one number and pretending it's settled. Start with the eruption itself. Yellowstone has produced 3 eruptions large enough to qualify as VEI 8, the largest category geologists use. The biggest of the 3, the Huckleberry Ridge eruption roughly 2.1 million years ago, ejected an estimated 2,450 cubic kilometers of rock, ash, and gas. For comparison, the 1980 eruption of Mount St. Helens, which flattened forests for miles, ejected about 1 cubic kilometer. Huckleberry Ridge was on the order of 2,000 times larger. That is the scale we are working with. Now, the first hour. Close to the vent, the immediate threat is the pyroclastic flow, a moving wall of superheated gas and rock fragments that can travel faster than 300 kilometers per hour, at temperatures up to 1500 degrees Fahrenheit. Based on the geological footprint of Yellowstone's past eruptions, that destruction zone extends roughly 100 kilometers from the vent in every direction. Nothing survives inside that radius through conventional means. This isn't a slow-moving disaster. It is measured in minutes. Further out, the danger changes from heat to weight. Ashfall from an eruption this size could blanket an area of roughly 1 million square kilometers with enough material to collapse roofs, choke engines, and shut down transportation and agriculture across multiple states. 1 million square kilometers is larger than the state of Texas and New Mexico combined. So, 2,450 cubic kilometers erupted. A 100-kilometer kill zone from the pyroclastic flow alone. 1 million square kilometers of lethal ashfall. 3 numbers, 3 independent lines of geological evidence, and scientists broadly agree on all 3. The 4th number is where honest disagreement starts. How much would this cool the entire planet in year 1? Here's what we can say for certain: large eruptions inject sulfur dioxide into the stratosphere, where it reflects sunlight and cools the surface. We've watched this happen at a much smaller scale. Mount Pinatubo's 1991 eruption, roughly 1,000 times smaller than Huckleberry Ridge, measurably cooled global temperatures by about 0.7 degrees Celsius for several years. That part is observed, not modeled. Scale that up to Yellowstone size, and the estimates start to spread. Older climate models projected a global temperature drop as large as 10 degrees Celsius in the first year, genuinely civilization-threatening cold. But a more recent study from NASA's Goddard Institute for Space Studies, published in the Journal of Climate, modeled the atmospheric chemistry more carefully and found that even the most powerful supereruptions probably wouldn't push global cooling past 1.5 degrees Celsius, because at a certain point the eruption starts working against itself. Enough sulfur dioxide saturates the stratosphere that additional gas stops adding much extra cooling. 0.7 degrees, observed at small scale. Somewhere between 1.5 and 10 degrees, modeled at supervolcano scale, depending on which physics the model emphasizes. That is the honest range. Anyone giving you a single confident number for this one is skipping the part where actual climate scientists still disagree. No figure in this video is invented. Where the science is settled, we gave you one number. Where it isn't, we gave you the range, and told you why it's wide.